We're going to be talking about cones. So you should be familiar with that shape in general, a traffic cone, an ice cream cone. A cone has a circle at the bottom and it comes to a point at the top. That is the shape we're looking at, and we're actually going to only be talking about the volume of these shapes. So volume in general is the amount a container can hold. It's the inside of a container. It's how much it can hold. It's how much fits inside. It's the capacity. It's how much it can carry. It's how much it would take to fill a container. It's literally the number of cubic units that will fit inside of a figure. I really like this picture off to the right. That shows exactly what I mean by cubic units. It's talking about little cubes. That's a cube, 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 that's a cube. It's literally showing you the number of those little cubes that will fit inside of a shape. So when you find an answer here, you're actually saying how many of these will fit inside of that shape. So we had some keywords that we just talked about. Also, we have units that are associated with volume. It's cubic units, or units cubed, or just units with an exponent of 3 on it. That exponent is cubed. So you might see inches cubed, you might see meters cubed. Whatever units we're dealing with, it's going to be those units cubed, because it's literally talking about the number of little cubes that will fit inside of that shape. When we're dealing with some real-world scenarios, you can be talking about filling a pool or an aquarium, the capacity of a shipping box, packaging products. So companies will want to package them very efficiently. They want to put as many soda cans in a box as possible. So the volume of that box and the volume of each can is important. Or we could be talking about baking, and we could be talking about the cake dimensions. That's just a few examples that you might see. All right, so we are going to be focusing mostly on cones here, but they are very related to cylinders, so I wanted to point out the connection there. First off, both of these equations use the radius. So the diameter goes all the way across. In that picture on your formula sheet, it's showing you the radius goes halfway across. So the volume, I'm going to just rewrite this. Volume is 3.14 times the radius squared times the height. We're multiplying each of those parts together. 3.14 times the radius squared times the height. You could see a second formula on your formula sheet. It says V equals that capital B times H. On your formula sheet, this is labeled. There's that little index at the bottom that says capital B stands for area of the base. The base is the bottom shape in any three-dimensional figure. So we're talking about the base as that circle. So this capital B stands for the area of the base, or the area of a circle. That's pi r squared. So you could see that capital B is just replaced with this value, 3.14 times the radius squared, because that's the area of the base. That's just an area of a circle. It's the exact same thing on the cone. You can see that pi r squared part can be replaced with that capital B. Again, that's just talking about the area of the circle on the bottom. So sometimes we'll just talk about it as the area of the base. Sometimes we'll talk about it as the radius. Either way, that's really the same information. Once you're told the radius, you should be able to find that capital B, that area of the base, because it's just the area of a circle. You're just using that equation to find the area of the base. One other thing I want to just point out here. You might be given extra numbers on this cone. The slant height, this is what I'm going to call the slant height. That's labeled as L. Again, that picture is directly from your formula sheet. But that's not really what we're using in this formula. We are using the height. The height always goes straight up and down. That H stands for the height that goes from the peak straight down to the middle of the base. All right, here we're going to do a couple examples just comparing a cylinder and a cone. So we're looking for the volume of this cylinder. So we're going to use pi times the radius squared times h. And I want to show you one really easy way to do this in Desmos. So I'm going to type that formula. I'm not going to type the equal sign. It really can't solve an equation, but I'm going to type the part that I want it to solve. Pi times the radius squared times h. So all I really did is type out this part of the equation. And now I'm going to say r equals some number and h equals some number, and Desmos is going to solve this for us. It's going to take those numbers and plug them in for us. So I really just have to decide what is my radius, what is my height, and then I'll just tell Desmos those values, and it's going to substitute those numbers in for me. The radius has to be halfway across. It's showing that 20 goes all the way across the circle on the bottom, so half of that would be 10. And the height just goes straight up and down there, that is 9. So I'm going to say r equals 10, h equals 9, and immediately Desmos is replacing those numbers. It's saying 10 is going to go in place of r, 9 is going to go in place of h, and this is going to be the value, 2,826 feet cubed. I'm going to do the same kind of thing for the cone. The cone equation's a little bit different. It's 1/3 times pi r squared times h. You should notice a connection between those. This is exactly the same. We just have that 1/3 in front. So I'm not really changing a whole lot in this equation. I'm going to put 1/3 in front and then times the rest of that. Same kind of thing. I just have to decide what's my radius here and then what's my height. The height I think is easier to distinguish there. The height is 4. The radius has to be halfway across that circle. The entire way across is 12, so halfway across is going to be 6. So my radius is 6, and my height is 4. So the volume of that cone is 150.72, and we're talking about centimeters, but we're talking about volume of that. Oops. That figure, that's supposed to be a 3. It's centimeters cubed there. So I really want you to notice the connection between these equations. Hopefully you noticed it before I said it, but really it's just multiplying the volume of a cone times 1/3. So what I would write here is that they are exactly the same, but the volume of the cone is multiplied by 1/3. So the volume of the cone is 1/3 of the volume of the cylinder. So if you have identical measurements, let's say we had the same radius and the same height, the volume of the cylinder is just going to be 3 times as big as the cone. Three of these cones would fit inside of a cylinder with the same dimensions. All right, so now we have some word problems that we want to solve. So the volume of cone is 588. Sorry, one second. Volume of a cone is 588 cubic units. So we're actually told the volume already. That's 588. And the height of the cone is 9. What is the area of the base? Remember, area of the base is represented by B, that capital B, on your formula sheet. So this is a little bit weird because we're not given the radius, we're not given the two numbers that we need, the radius and height. We're given the volume and the height. So I want to think about my equation here. Volume of a cone is 1/3. I could write it as pi r squared times h, or I could write it as capital B times h. I have those two formulas there. I'm writing that one because they ask directly for that capital B. And now I'm going to substitute my numbers in. This part you can't do in Desmos because it can't solve equations. I'm going to just substitute them in to my equation here. And then think about how to solve that equation. I'm trying to get capital B by itself, so I'm trying to solve that equation. First thing I'm going to do is just multiply these two numbers together. 1/3 times 9 is just 3. So that's 588 times 3b. I multiplied those two numbers together just to simplify the right side of that equation. And now I want to solve the equation. I want to get b by itself, so I'm canceling out that multiplication by dividing by 3 on both sides. And we find that capital B, or the area of the base, is 196 inches squared. We're talking about an area there. That's why this is squared, not cubed. We're not talking about the volume. This measurement would be cubed. last word problem together. An ice cream shop is introducing a new novelty cone with a diameter of 8 centimeters. So immediately I'm thinking, well, my radius is 4. I can't use diameter there. I need to change that to radius. And a height of 12. How much would it cost to fill the entire cone? Fill the cone says I'm finding volume with premium ice cream if it costs 2 cents per cubic centimeter. So I have to figure out the cost of this after I figure out how much it's actually going to take to fill this. So I'm talking about a cone again, 1/3 times pi r squared times h. You could substitute those in by hand if you really like, but I'm just going to use Desmos. I already have the equation loaded up in there. Now I just need to change my radius. So it's the exact same equation. This is really why this is convenient. As you're going from one problem to the next, you just keep that equation in there. You change the radius, you change the height, and that is the volume of that cone. All right, that's not the final answer though. That's just telling us how much it's going to take to fill this. The volume is 200.96. Now I want to figure out the cost if it's 2 cents per cubic centimeter. I know the number of cubic centimeters, that's the volume. That word per means multiplication. I'm taking that 2 cents and multiplying it times the volume that I got. I'm just going to take this number and multiply it times 2 cents. And that shows me that it's going to cost about $4. It's really $4.02 when I round to the hundredths place to fill that entire cone. All right, you should be able to do these 4 on your own. I want to point out something about number 3. We're relating a cone to a cylinder with the same base area and the same height. So they're basically the same shape. One is a cylinder, one is a cone. They have the same base area, so the same circle on the bottom, and the same height. Think about how the equations are related for the volume of each of those. All right. Hopefully you're able to complete that on your own. Try your best. Hope this helps.